Okay, hi students, welcome to the ABK Chemistry channel, and this is the ABK Chemistry. Now today we are going to discuss about very important topic regarding for all your competitive examinations like KSET, MSET, NEET examinations, JEE mains examination, JEE advanced examination. For every competitive examination, one of the important topic from structure of atom. From structure of atom, it is a physical chemistry part and very important topic. What is the topic here is nothing but why half filled and full filled configurations are more stable than compared to unfilled configurations. That is the config. Very important topic, students. Okay, why half filled and full filled configurations are more stable. Okay, now before going to discuss about this topic, now come to the discussion about some basic fundamentals, some basics regarding configurations. Basics regarding configurations. See, here I am going to taking subshell. Here I am going to taking one subshell. I am taking here subshell, and what is its half filled configuration? What is its half filled configuration? And what is its full filled configuration? What is its full filled? What is its full filled configuration? And what is its unfilled configuration? Unfilled configuration, what is that is there? Unfilled configurations. Okay. For example, I am going to taking S subshell. I am going to taking which one, students? S subshell. If you take full filled only one s orbital is there here. Full filled configuration is nothing but only total one orbital capacity is equals to 2 electrons. That is only if one electron is there, that is called half filled. If for example, if you take only one s subshell is there, if 2 electrons are there in that, that will be considered as a which one? Full filled configuration. Other than this, nothing, I mean unfilled configuration is not there. Zero filled configuration, we have to take in that one. Zero filled configuration. Okay, I mean it is half filled, it is full filled configuration. For example, you have to take for p subshell, you have to take for p subshell. Now total in p subshell, p total 3 p orbitals are there. Total how many p orbitals are there? 3 p orbitals are there. In this half filled configuration is nothing but one orbital capacity is equals to how many electrons, students? 2 electrons. Total how many orbitals are there in p subshell? 3 p orbitals are there. Each p orbital capacity is equals to 2 electrons and one orbital capacity is equals to only 1 electron. That is 3 orbitals, nothing total. Half filled configuration is nothing but total 3 electrons are present with the same spin. Okay, and next full filled configuration is nothing but what is the full filled configuration here? Now this is parallel spin, anti-parallel spin, like that it is present. Total it is 6 electrons are present in the shell. 6 electrons are present in the shell. It will be considered as a full filled configuration. It is P3 and it is P6 configurations are most, I mean half filled and full filled configuration. Other than this P3 and P6, what are there? That is P1 is there, P2 is there, and next P4 is there, and next P5 is there. And these three configurations will be considered as a which one? Unfilled configuration we have to take. Okay. Next, I am going to taking D subshell. I am going to taking here D subshell. D subshell, in how many orbitals are there in D subshell are nothing but total 5 orbitals are there in D subshell. Total how many orbitals? So 5 orbitals. In these 5 orbitals, each orbital capacity is equals to 2 electrons. So total 5 orbitals are nothing but half filled is nothing but only 5 electrons are present like this with the same spin are present like this. And now here, if you take d orbitals, full filled configuration is nothing but total orbitals will be filled with 2 electrons each orbital, and total here now like this first half filled, next it will be going to pair to start and it will be going to pair this start. Okay, total D10, and this is the D5 configuration is half filled and D10 configuration is the full filled here. Other than these two configurations, what are the remaining? D1, D2, D3 and D4 are there, and next D6, D7, D8 and D9. Okay, and these 8 are the unfilled configurations for which subshell? D subshell. Okay. And next, if you take for example F subshell, what are the F subshell is a total how many orbitals are there in subshell? Total 7 orbitals are there. 1, 2, 3, 4, 5, 6 and 7. Now each orbital capacity total 2 electrons, but half filled is nothing but only one electron I am going to taking here. 4, 5, 6, 7 orbit. Okay, that is F7 configuration is the which configuration? Half filled configuration for which subshell? F subshell. And next total 7 orbitals I am going to taking here. Total 7 orbitals 3, 4, 5, 6 and 7. Each orbital first it will be singly occupied, and next it will be going to start with the pair. I mean like this, total 1, 2, 3, 4, 5 and this is 6 and this is 7. This is 7. I mean this is what is that F14. F7 is the half filled configuration. F14 is the full filled configuration. Other than this, what are there? I mean F1, F2, F3, F4, F5, F6, F8. F7 is the which one? Half filled. Other than that, F8 and F9, F10, F11, F12, F13. What are these? These are all which one, students? Unfilled configurations. Like that, see why this half filled, P subshell half filled is P3, full filled is P6, D subshell half filled is D5 and full filled is D10, and F subshell half filled is F7 and full filled is F14. These are the half filled and full filled configurations of different subshells I give here. Why these half filled full fills are more stable than compared to unfilled? Half filled full fill are more stable than unfilled. Half filled full fill are more stable than compared to unfilled. What is the reason behind of the stability of this half filled and full filled configurations of different subshells? That is the topic we are going to discussing now. It's very important, students. Now I hope you are understand what is half filled, full filled, unfilled. Now come to the discussion. Next to why these are more stable. What is the reason behind of this one is nothing but just now come to the discussion about next to continue to this one. Continue to this one, just listen carefully. What is the reason for this one is nothing but see, listen students carefully. First I am going to taking stability energy. Stability energy is mainly depends on two factors. Number one is exchange energy, and another one is pairing energy. Another one is which one, students? Pairing energy. Very important students. Now what is this exchange? I mean stability energy is main stability of anyone. Just why the half filled full filled configurations will be gets the more stable is nothing but that is why stability is nothing but it will be majorly depends on two energies. Number one is exchange energy, another one is pairing energy. The stability energy is equals to exchange energy minus pairing energy. You have to remember that formula. By based on that, we can tell why half filled and full fills are the more stable. Okay. Now, stability energy is always is equals to exchange energy and pairing energy. What is the formula? Stability energy is equals to exchange energy minus pairing energy. Okay. Now, in this, first we should want to know what is that, what is the exchange energy and what is the pairing energy, that we have to know first. Okay. Now I am going to taking students here carefully here. Now I am going to taking for first D4 configuration. I am going to D4 and D5 and D6 configurations are I am going to taking here. 3 configurations. Listen carefully. Very important. D4, D5, D6 configuration. In these D4, D subshells are total how many are there, students? Total how many are there? Total in D subshell total 5 D orbitals are there. What is its half filled configuration? D5 is the half filled configuration and these two are the unfilled configuration. Why D5 is the more stable than compared to D4 and D6? That is the main topic here. Okay. Now, what is the stability order of these 3 configurations? D5, D6, D4. Already I told D5 is the half filled, it is more stable. Why it is more stable compared to these two? And after this one, which will become D6, D4. What is the reason? And everything we are going to discuss here. First, to come to the discussion about what is exchange energy, I am going to discussing here. First, what I am going to discussing here, exchange energy. First, I will take D4 configuration. I am taking students here. Listen carefully. It little bit take some more time. Just you have to listen carefully. What will be happening here? Exchange energy. First, I am going to taking exchange energy. What is exchange energy is nothing but, now I am taking D4 configuration. D4 configuration I am going to taking here. Total how many d orbitals are there? 5 d orbitals. Each orbital has the how many electrons? 4 electrons it is there. Each orbital has one electron. 4 orbitals has the 4 electrons. Which configuration I taken here? T4 configuration I taking here. Exchange energy for which configuration? D4 configuration. See here, how to calculate exchange energy is nothing but exchange energy formula. Exchange energy is equals to n into n minus 1 divided by 2 formula you have to apply. What is the formula for exchange energy? N into n minus 1 by 2 formula you have to apply. In this formula, n is equals to number of electrons with same spin. Number of electrons with same spin. Keep in mind, students. Number of electrons with same spin. Now here, in this configuration you have to see here, and this is all electrons will be having same spin. That is, all electrons are parallel, not anti-parallel. All electrons their spin is clockwise. All electrons their spin is clockwise in these 4 electrons. Now here, see, exchange energy is nothing but, for example, I am going to taking the first electron. This electron will be exchanges this electron. Why? Because both will be having the same spin. And this electron will be exchanges this electron is also. Why? Because all will be having the same spin, and which will be having the same spin. No? One electron will be exchanged by another electron. That means this electron will be exchanges this one, and this electron will be exchanges this one, and this electron will be exchanges this one is also. With respect to first electron, how many exchanges are possible, students? 3 exchanges are possible. That is, and this is first exchange, this is first one, this is second one, this is third one. Total, how many exchanges? 3 exchanges. And now, with respect to second electron, how many exchanges are possible? 2 exchanges are possible. Already, with first and second, already it is completed here. Again, don't come to this like this. Okay, with respect to this one, how many exchanges are possible? 2 exchanges are possible. With respect to third electron, how many exchanges are possible? Only 1 exchange is possible. How many exchanges are possible? 1 exchange. That means in D4 configuration, total, what is the total exchange energy here you are observing? 3 plus 2 plus 1, total 6 exchanges are possible. You have to calculate here exchange energy. Exchange energy is equals to what I told, n is equals to number of electrons with the same spin. Total 4 electrons are there with the same spin. That is 4 into 4 minus 1 divided by 2. That is 4 minus 1 is nothing but 3. 3 4 is 12. 12 by 2 is equals to 6 we are getting here. What we are getting here? 6. 6 is equals to what, student, here? Exchange energy. 6 is equals to which one? Exchange energy. Now coming to the stability I am calculating here. Stability energy is equals to exchange energy minus pairing energy, it is there. Is it or not? Now exchange energy, how much I got here for D4 configuration I am calculating, students. For D4 configuration I am calculating. Now exchange energy is equals to 6 is there, minus pairing energy is there, any pairing is there, any pairs are there? No pairs are there. That is 6 minus 0 is equals to 6. So the total stability energy of which configuration? D4 configuration is 6. The total stability energy of D4 configuration is equals to 6 we have to take. Okay. Next, I am going to taking exchange energy, stable for D5 configuration I am going to taking, students. For which configuration I am taking here? D5 configuration I am going to taking. D5 configurations are nothing but total 5 I am taking D-subshell here. D-subshell. Now in D-subshell 1, 2, 3, 4 and 5. Okay, total 5 D-subshells I am taking here. Now this is the first two, total D5 configuration is nothing but each orbital will be filled by the single electron. Now here all electrons will be having the same spin, clockwise spin is there. That means this electron will be exchanges all 4 electrons, this electron will be exchanges 3 electrons, this will be exchanges 2, this will be exchanges 1. Now here see, this will be exchanges this one, this will be exchanges this one, and this will be exchanges this one, and this will be exchanges this one. Total with respect to first electron, how many exchanges are possible? Total 4 exchanges are possible. Now with respect to second electron, now 1 and 2 and 3, how many exchanges are possible? 3 exchanges are possible. With respect to third electron, how many exchanges are possible? 1 and 2. 2 exchanges are possible. And with respect to the fourth electron, how many exchanges are possible? Only one exchange is possible. How many exchanges are possible? How many? Only one exchange. Here 4 plus 3 plus 2 plus 1. How many total? 6 plus 4, 10. 10 exchanges are possible. How many exchanges are possible for D5 configuration? 10 exchanges are possible. Now I am calculating stability energy. Stability energy is equals to exchange energy. How much is the total? 10 is there. 10 minus. Is there any pair? Pairing energy is nothing but is there any pairs? No pairs. No pairs. Stability energy is equals to exchange energy minus pairing energy. Stability energy is equals to exchange energy 10 no? Minus is there any pair? No pair here. That is pairing energy is 0. That is equals to 10. So the total stability energy is equals to how much is there? 10 is there. For D4 configuration, stability energy is equals to how much is there? Just 6 it is there, stability energy. Stability energy 6 is there. Okay, that one you have to keep in mind. And next I am going to taking D6 configuration. I am going to taking. Which configuration I am taking? D6 configuration. If you take D6 configuration here, students, if you take D6 configuration here, now or otherwise you have to take here exchange energy also you have to take here. Exchange energy you have to take calculate here. Exchange energy for D5 configuration n into n minus 1 divided by 2. That is n is equals to number of same spin electrons. 1, 2, 3, 4, 5 electrons are there. That is 5 into 5 minus 1 by 2. I mean here 5 minus 1, 4. 4 5 is a 20. 20 by 2 is equals to 10 we are getting. Directly by applying this formula directly we will get if you know the number of same spin electrons. Okay, like that also we are getting here. Okay, now here I mean for D6 configuration, what is the D6 configuration also you have to calculate. This is for D5 configuration. This is for D5 configuration. Now for D6 configuration you can calculate, that is n into n minus 1 divided by 2. Now n is equals to how many here? See 1, 2, 3, 4, 5, 6 electrons are there for D6 configuration. Same spin electrons 1, 2, 3, 4, 5 are there here. 5 are there. I mean clockwise spin is how many are there? 5 are there. 5 are nothing but what we are getting here, clockwise spin no anti-clockwise spin difference separate you have to take. Clockwise and anti-clockwise you have to take like that. Okay. Now here if one electron is anti-clockwise, only one electron is there, that you don't count. No need to count that one. If another electron is there, anti-electron for D7 is there here. Now this will be exchanges this one. Okay. See, keep in your mind students. Only the first electron will be exchanges 1, 2, 3, 4. And this will be exchanges this 3. This will be exchanged like that it will be happen. But what is this anti-clock spin is there? This electron does not exchanges anything. With respect to this electron, the exchange energy is 0. With respect to this electron. Okay. If any other anti-clock electron is there, this will be exchanges this one. Okay, like that you have. I am going to doing for only D6 configuration I am doing. Now here only parallel spin you have to take here, that is 5. Okay, this one I will calculate later. Just here with respect to this one you have to see. Now with respect to this electron, I mean how many exchanges are there? How many exchanges are there? Already we did that one. 4 are there with respect to 4. With respect to this one, how many are there? 3 are there. With respect to this one, how many are there? 2 are there. With respect to this one, how many are there? 1 is there. Okay. So total here for D6 configuration, now here is equals to 5 into 5 minus 1 by 2. 5 into 5 minus 1 by 2. It is equals to total we are getting here 10. As usually what we are getting here for D5 you are getting 10. For D5 configuration, for D6 configuration, for both configurations, the stability, the exchange energy is 10 only. Exchange energy is 10. But coming to the while calculation of stability energy for D5 configuration, exchange energy minus pairing energy is there. Exchange energy is 10, pairing energy is 0. Total we are getting 10 here. But for D6 configuration, I am going to calculating stability energy, exchange energy minus pairing energy. Exchange energy minus pairing energy. Exchange energy is 10, we got generally, minus pairing energy. What is there? Here one pair is there, student, here. One pair is there, that is minus 1. 10 minus 1 is equals to 9 where? So the stability energy is 9 only for which configuration? D6 configuration. The stability energy is only 9 for which configuration? D6 configuration. Very clear students, very clear here. Just listen carefully. For D4 configuration, total stability energy will be depends on exchange energy and pairing energy. How to calculate exchange energy? N into n minus 1 by 2 formula. What is n? Number of same spin electron. For D4 configuration, 4 same spin electrons are there. If you calculate exchange energy for D4 configuration, we are getting 6. Stability energy is equals to exchange energy minus pairing energy is equals to total 6 we are getting for D4 configuration. For D5 configuration, exchange energy how to calculate it, total 10 we are getting. Stability energy is equals to exchange energy minus pairing energy is 0 for D5 configuration. Total again we are getting 10. But for D6 configuration, exchange energy we are calculated 10. Exchange energy we are calculated how much? 10. Stability energy we are calculated, exchange energy minus pairing energy. Exchange energy is 10, but one pair is there here. For D5 no pair. 10 minus 1 by 9. 10 minus 1 we are getting total. 9 is the stability energy for which configuration? D6 configuration. By based on this, can you tell what is the stability order of D4, D5, D6 is nothing but D5 is the more stable. D5 is the more stable. D5 is the more stable than D6. D6 is more stable than D4 configurations. Very, very important. Stability order. Stability order of this one. D5, D6, D4. D5 is more. Why? Because its exchange energy is more. Exchange energy, stability energy is more for D5 configuration. Don't consider only exchange energy. If you keep in your mind, exchange energy is same for D5, D6 configurations. But why D5 is more stable is nothing but pairing energy is there for D6 configuration. One pairing energy is there. We have to subtract pairing energy from exchange energy. Exchange energy. That is the reason why the D5 is more stable than D6 and D4. Like that the same, for example, chromium is more stable than compared to vanadium and manganese. Like that copper is also, you have to take copper. Why copper is more stable? D10 configuration is more stable than compared to D9. I mean copper is more stable. Copper you have to take here, 1 minute I am going to taking here. D10 is more stable. What is the reason for that one? See here, you have to calculate, you have to do same thing for which one? D10 and D9 and D10 configurations you have to take. D9, D10 configurations. Okay, if you take D9 configuration here, D9 configuration, total only D9 I am going to taking here, D9. You have to take for example like this. Total how many electrons are there, students? Total, I mean here 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons I am going to taking. 9 electrons. Can I calculate what is exchange energy for this one? Exchange energy is equals to N into N minus 1 divided by 2 formula. First here you have to observe clockwise spin is there and the anti-clockwise spin is there. This electron, clockwise spin will be replaces these 4 electrons. And what is this anti-parallel is that this will be replaces only 3 electrons here. Only 3 electrons. That's why first I am calculating clockwise. First I am going to calculating clockwise electrons exchange I am going to calculating. Clockwise here 1, 2, 3, 4, 5 electrons are there spin. That is 5 into 5 minus 1. 5 into 5 minus 1 by 2. 5 into 5 minus 1 by 2. I mean 5 minus 1 4, 4 5 is 20, 20 by 10 is equals, 20 by 2 is equals to 10. Exchange energy for with clockwise. Now I am going to calculating exchange energy with anti-clockwise I am going to calculating. Anti-clockwise total only 4 electrons are there. N value is equals to 4. 4 into 4 minus 1 divided by 2 we have to take. 4 minus 1 is equals to 4 minus 1 3, 3 4 is 12, 12 divided by 2 is equals to 6 we are getting. How much we are getting? 6. Clockwise and anti-clockwise. Clockwise is 10 exchange energy. Anti-clockwise is 6. Total 10 plus 6 is equals to 16 it is there. 16. Now I am calculating stability energy. Stability energy. Which one I am calculating? Stability energy is equals to exchange energy minus pairing energy you have to take. exchange energy is equals to 16 minus how many pairs are there? 1, 2, 3, 4 pairs are there. 16 minus 4 is equals to 12 we are getting. How much we are getting? 12. 12 is stability energy for which configuration? D9 configuration. Which configuration? D9. Now I am going to taking for next D10 configuration. I am going to taking D10. D10 configuration is nothing but how many electrons are present, students? Total 10 electrons are present. D10. Total 10 electrons. 1, 2, 3, 4 and 5 electrons. Okay. 5 orbitals. Total how many electrons? 10 electrons. In these 10 electrons, 5 electrons are the clockwise spin. Another 5 electrons are the anti-clockwise spin is there total. Now what is the exchange energy? I am going to calculating here. Exchange energy is equals to n into n minus 1 divided by 2. First clockwise I am going to calculating. Clockwise. Which one I am going to student? Clockwise. Clockwise total how many electrons are there? 5. 5 into 5 minus 1 by 2 it is equals to same formula. That is what you are getting here 10. Clockwise is 10. No? Anti-clockwise is also 10 is there. Is it or not? Anti-clockwise is also 5 electrons. 1, 2, 3, 4, 5 electrons are there. 5 electrons are nothing but 5 into 5 minus 1 divided by 2. Same we are getting 10. 10 here. So what we are getting here? 10 plus 10 is equals to 20 we are getting here. 10 plus 10 is equals to 20. Total exchange energy is equals to 20. Stability energy is equals to? Stability energy is equals to exchange energy minus pairing energy. Exchange energy is equals to 20 minus pairing energy is equals to 5. 20 minus 5 is equals to 15. 20 minus 5 is equals to 15. Total 5 pairs are there. Pairing energy is 5. Exchange energy we are calculated 20. 10 is clockwise, 10 is anti-clockwise. 20 minus 5 is equals to 15. With the D10 configuration, this one is 15. With the D9 configuration, this one is 12. So which one is more stable? Stability energy for D10 is 15. Stability energy for D9 is just 12 only. Which one is more stable? Which one is more? D10 configuration is more stable. Like that, that is why the reason half-filled and full-filled configurations are more stable than compared to unfilled configuration because of exchange energy. Because of exchange energy, it is the main factor. At the same time, pairing energy is also it is one of the important factor. It is one of the factor. At the same time, symmetry is also there for D5, D10, P3, P6 like that. F7, F14. There more number of exchange energy value, stability energy we are getting for F orbital case. Okay. So this is about what is this information, students. Okay. Now ABK sir, yours ABK sir, always with you. Thank you so much.